So I think I'm recording. Let's take a look at this problem. We've got a polynomial function of fifth degree. Now again, I want to make sure that I have factored out the greatest common factor, and I can see that there is a greatest common factor. So let's do that before we jump in and try and start looking at the factors of the constant term and the leading coefficient. First, our expression needs to be in standard form and complete, not have a greatest common factor. So 8 divides all of these numbers, and x is common to all of these. So I'm going to factor out an 8x. What I would have left would be x to the fourth power, x squared minus 20 minus 20. All right. Now, when I'm going to go in, I'm going to focus my attention on this polynomial. So I need to write it in it is in standard form, but to do synthetic division, I'm missing x cubed terms and the linear term x to the first. So I'm going to rewrite this to help me out. So I know that this graph is passing through the origin because I have a factor of x here. I'm going to rewrite this 1x to the fourth, 0x cubed, 1x squared, 0x minus 20. Now I'm ready to focus my attention on this problem, on this polynomial, when it comes to identifying the factors of the constant term and leading coefficient. And at least for now, these questions will all be in reference to this new polynomial. So, factors of my constant term, this negative 20. I've got plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. Those are the factors of this 20. Now my leading coefficient, at least that's prime and just 1. So this polynomial function that I have highlighted, if it does cross the x-axis, and if it crosses at a rational number, then it will be in this list. Let's write it out. No guarantee that it does cross at any of these values. We saw that in a previous problem that we could only factor it so far, and the other x-intercepts were irrational numbers, and in our rational zero theorem, it was just had its limits. It couldn't actually help us solve that problem and find all of the zeros of that function. We went as far as we could. All right, so let's jump in and try to start doing synthetic division on these values and see if we find a zero remainder. So remember, I'm working with what's highlighted here, the 1, 0, 1, 0, negative 20. Well, 1 is not going to work. I think you can see number-wise that this just didn't grow fast enough to. So 1 is not a 0. And I don't know. Let's try like one of these 10s. We've tried. Well, let's try negative 1 to get it out of the way, and we'll cross it out. So I know this one's not. Now I'm going to jump around in search of a zero remainder. Let's try these larger numbers. Let's try 5 and 10. Ten times 1, 10. 10. Well, here's 100. So maybe that wasn't that brilliant of an idea. Because now times that's definitely not going to be it. So let's come back down and try something smaller. Let's go to 4. Maybe I should have just kept going in order. Like I say, my mental arithmetic is not as good as probably you guys. Boy, I'm definitely not having any luck, am I? So 4 times this guy, there's no way that's 0. So let's try negative 4. So this can sometimes be the frustrating process here. Is that a 68 and then negative 68? Well, again, this is going to be too big. It's not going to cancel that 20. Maybe I should try the 2 or the negative 2. Yeah. Huh. I am just not very good at mental. I thought I was expecting a value larger. Okay. Sorry about that. So you're probably screaming, hey, try 2, idiot. All right. So 2 is definitely a factor. Let's see what we have here. Well, this will get this x to the 4th is now starting out x cubed, and well, I could factor by grouping. I can factor this. Let me show you that. So actually, this is a special case where we can stop and factor it. Now, I do believe there's more in that list, but let me show you that factor by grouping, or at least what I think will be the answer. So I've got this f of x. We already originally recognized there was a greatest common factor of 8x. Then we worked with the reduced polynomial and said that it had a factor of x minus 2. Because remember, if x equals 2 is a 0, then in factored form it's x minus 2. Well, now, if you go backwards, this is the constant. This is 1, 2, 3. That 1 is 1x cubed. 2x squared plus 5 plus 10. All right, now let's take this to another page. I claim that we can factor this, that we have the skills to factor that. Normally with an x cubed we won't have. Let's put it in the form of a table. Now, in the past when you've used tables with trinomials, you've always entered the information diagonally. I'm going to go straight across. 1x cubed, a 2x squared. I guess I didn't need that positive there to tell you the truth. Did I? 5x and 10. Horizontally here, these have a common factor of 5. And vertically here, these are both even numbers. They have a factor of 2. 5 times 2 is 10. So far, so good. Horizontally here, the numbers are relatively prime, but they both share a common factor of x squared. And x squared times 2 is 2x squared. Vertically here, these both share a common factor of x. And x squared times x is x cubed. So we can factor what I've highlighted there into x plus 2 times x squared plus 5. Now we cannot factor x squared plus 5 any further. So, and that's x squared is never going to be a negative number. It's never going to cancel with this 5. This factor is not going to contribute towards this product equaling 0. To find the x-intercepts, we let y equal 0. So when we look at this factor contributes towards, if x were 0, that whole product is 0. If x were 2, 2 minus 2 is 0, and 0 times anything is 0. If x were negative 2. But right here, x squared plus 5 equals 0 has complex numbers as solutions, and we're not working in the set of complex numbers. We're not saying to take plus or minus I times the square root of 5. Now, those are considered zeros of the function. They're complex, and they do contribute towards adding up to that original. This is a fifth degree, so we had two complex numbers, 2, 3, 4, 5. Those are all the zeros. You know, we didn't have to necessarily find what it was. We could look at the degree of each factor. This is a degree of 2. This a degree of 1. 1, 1. So when it comes to this one, was also wanting us to indicate if the graph touches or turns. Well, x squared plus 5 doesn't contribute towards crossing the x-axis at all. So what we have found here is that the zeros, the real zeros, the zeros that are real numbers, are x equals 0, x equals 2, and x equals negative 2. And the multiplicity of each of these zeros, I'm going to abbreviate multiplicity, just mult, are all 1, and those are odd numbers. And I know that if the multiplicity is odd, then the graph crosses the x-axis at these zeros. So when I'm trying to determine how does this graph intersect the x-axis, well, it's always going to be either a cross or a touch and turn, and for all of these guys, it's a cross. That's a sorry looking word for cross, isn't it? Sorry about that. All right, so that is my answer. Even though this was of degree 5, I only had 3 real zeros. The other 2 zeros to this function are complex numbers. And in the Cartesian plane with the x-axis and y-axis, the way we've defined it right now, that then we can't plot those complex numbers. Later, we will learn a way to plot complex numbers, but not until we get to skill packet 6, I believe it is. Anyway, I hope that helps. And this table is what they were asking me for. This is my final answer.